Okay, so in this video, I want to explain to you the idea of angle of elevation or the angle of depression. So suppose we have an observer here. So suppose we have an observer, and if the observer look upward at some, let's say a tall building or something, then from the observer's eyesight or the eye level, we call this the horizontal. So let's call that the horizontal. So as the observer is looking upward towards something, we create this angle from the horizontal to the observer's eyesight. And that's what we call an angle of elevation. Okay, so that's how pretty much you can understand what the angle of elevation is. Now take another scenario. So say we have a tall building here or something, and we have an observer up here. So someone is observing it, and the observer looks down somewhere here at something. Let's just say a park or something. If the observer is looking downward from that tall building, looking at this part right here, from the observer's eyesight, we label that our horizontal. So this is the horizontal. And from there, where the observer is looking, we create an angle, and that angle is the angle of depression. So this is what we call an angle of depression. So pretty much the way you want to relate these two angles is using geometry. So suppose we create two parallel lines. Suppose we have a parallel lines. And so these are our horizontal. Okay, so that's one. Let's call this the second one. And then we cut through the middle like that, and we create angles. So from this picture, we can say that this angle is an angle of elevation. So if we have an observer here and looking at upward toward something up here, say this is an angle of elevation. And similarly, if we have an observer here and it's looking downward towards something, we create an angle of depression from the horizontal. So this is the angle of depression. So you can see that these angles are actually alternate interior angle. And you know from geometry that these angles are congruent. So we're going to try to use this idea to do a couple of examples. So let's take a look at our first example. So this is our first example. So we're going to draw a picture so that way we can understand what's going on here. So we have a 16 feet ladder leans against the building so that the angle between the ground and the ladder is 69 degrees. So suppose this is the ladder. That's the ladder. It's leaning against a building. Let's call that the building. And so let's suppose this is the ground. So the ladder, the building, and the ground. So the ladder is 16 feet tall, and it's leaning against the building, and the angle between the ground and the ladder, so that's this angle, is 69 degrees. We want to know how high does the ladder reach on the building. So this is what we're looking for. That will tell us how high the ladder reaches the building. Okay, so what we're going to do here is we will try to use a trig ratio that we can use to relate what's given to us. So we're going to label our opposite, adjacent, and hypotenuse. So as you all know that if this is the angle, across from it is the opposite side. That means this is the adjacent side and this is the hypotenuse. So we want to use x and 16 in the picture. So that means we have to use opposite over hypotenuse. So the trig ratio that will relate these two variables is sine. So you know that sine of an angle is equal to opposite over hypotenuse. That's the definition of it because we have created a right triangle. So we're looking at 69 degree. So we can say sine of 69 degree is equal to opposite, which is x over hypotenuse, that's 16. So now we can multiply 16 on both sides to solve for x. So we know that x is equal to 16 times sine of 69 degree. Now this is an acceptable answer if you don't have a calculator, but if you do have a calculator, go ahead and plug this in your calculator. You'll see that this will estimate to about, let's see, this would be about 14.9, which we can estimate it to 15 foot. So that's how high the ladder reached on the building. Okay, let's take a look at the next example we have. So here's our next example. So we have an observer standing on top of a vertical spots a house in the adjacent valley at an angle of depression of 12 degrees. The cliff is 60-meter tall. How far is the house from the base of the cliff? So suppose this is so let's draw the cliff. So suppose this is the cliff and we have someone up there and we're going to measure the angle from his or her eyesight. So from the observer's eyesight. Now here's the house. Let's just say that's the house. So the observer up there is looking at the house. So let's draw that. So looking at the house. So from the eye level, right here, that's the horizontal. We create an angle of depression that's 12 degrees. And we're also given the cliff is 60-meter tall. So this is 60-meter tall. Well, we want to find how far is the house from the base of the cliff. So we're looking for this. That's the portion we're looking at. Now here we want to use the angle of elevation because we're given the angle of depression. So there are two ways really you can do this problem. You can figure out the angle of elevation by using the congruent relationship or the alternate interior angle we mentioned earlier. So as you can see that, if I extend this just a little bit more, so that's the horizontal and that's the horizontal from the observer's eyesight. And then as you're cutting through the middle, we're creating interior alternate angle. So if that's 12 degrees up there, then this is also 12 degrees because they're interior alternate angles. So these angles are equal. Now you can also think about it this way. Here we create a 90-degree angle. So if that angle is 12, then that means this angle is 78 degrees. You can also use that if you want. But we're going to stick to that 12 degrees as the angle of elevation from the base of the house to the observer. So we can use the trig ratio to relate the sides we're given. So if 12 degrees is what we're given at the bottom, so that means across from it, it's going to be our opposite side. And this is the adjacent side. And this would be the hypotenuse. So in this picture, we want to relate opposite and adjacent. So we know that tangent of an angle is defined as opposite over adjacent. So therefore, we have an angle that's 12 degrees. So tangent of 12 degrees is opposite 60 over x. And finally, by solving for x, we get x is equal to 60 over tangent of 12 degree. Okay, and this is approximately 282. So that's how tall, that's how far the house from the base of the cliff. Okay, so I hope this idea of angle of elevation and depression makes sense. Okay, see you next time.